So let's start. Once again, hello, dear students. And today's lecture, I think I will have two parts. First, we will talk about errors in Python and how to deal with them. And the second one, if I have time, we will start to write some example project where we will utilize all our knowledge about objects, about reading from files, and so on. So let's start with Python errors. First of all, in all programming languages, in all paradigm, you must understand that errors can be different types. I'm not talking about Python types of errors, but about differentiation of syntax errors and runtime errors. So what's the difference? Syntax errors is your errors as programmer when you write in your code. So for example, you forgot to write semicolon or define function without def or something else. So syntax errors are all about your code. And the interesting thing that Python interpreter checks all syntax errors before running your program. Because you know from our first lectures that Python interpreter gets the code of your program, read it, and translate it into the bytecode object. And after that, only implement this bytecode. So all syntax errors will be triggered before running your program. Let's check how it works. So let's create some toy example. For example, we define some function foo, forgot semicolon, and here we have nothing. So this program looks like we do not trigger to execute the function foo, because in our main region we have only one operation. We print hello, but what will be if we run it? We have syntax error, the invalid syntax. So this is exactly it. Python read all your code line by line and try to transfer it into the bytecode, but it can't do it because we have no semicolon here, and this is a syntax error. And you must understand when you have syntax error, your code is not running, so you can't have runtime errors. So first of all, you must correct all your syntax errors, and after that, run your program. Actually, it's not really true in interactive platforms like Jupyter Lab. So I can run here, for example, Collab. Because in Collab, we have chunks. in interactive Python environments. So I want to create new notebook here. So for example, I have the same function foo here with a syntax error. And of course it has this error, but after that I can run another chunk. So you need know all chunks to be correct. Interpreter, so the core, where is the core here? Runtime tools. I forgot where we have information about kernel of the Python. This is our resources. This is the restart of the kernel. Okay, in Collab we have no information about our Python kernel, but we have interpreter running and it deals with each chunk like this is a separate file. So here we have invalid syntax only for one chunk. This is the difference between interactive Python environments and Python interpreter working with your written files. So runtime errors. These are really interesting errors because it's not about your code. It's about your abstract thinking and how thing goes on in your runtime when you have your structures, your relations between structures, some maybe mathematical errors, and so on. So runtime errors happened only if you have no syntax errors and program is running. The best example for runtime error, for example, is the division by 0. So if we have some variable x and we divide it to y, if y will be 0, we will have a division by 0 error. Let's try to demonstrate it. So we have 3 calls of function foo. First call we have with 1, so it will be the legit number 1000. Next, we will have an error, and this is the operation that will called after runtime errors. Let's look what we will have. So first, we have a result from the first call of function. Okay. Next, we have a zero division error because we can't divide by zero, and we will have such an error from our Python interpreter. With error, we have our call stack. So it was called in line 5 here, and we go into the function foo, where we have return 1000 divided by y. And we can't see the next operation. We can see the result of running foo function with argument 2, because every runtime error without any option, without any additional parameters and syntax, it stops your program evaluation. So program will stop when runtime error will be raised. But of course, in Python, we have special instruments to deal with it, to try first of all, to try to show for user, for programmer, that you have error, but in case you have error, you do not need to stop your program. And for such purposes, we have a try except blocks. So how it looks like. We have such construction. The special word try. Here we write our code that can raise an exception. Exception is a synonym for error in Python. So we called it exception because actually in many different programming languages, this is called exception, and in Python it's explicitly exception because these are objects that were inherited from the parent object exception. So code that can raise exception. It can or cannot, so it depends. After that, we have except, special word except, and in different variants, we have explicitly right here the word exception and semicolon. Here, how to treat exception. After that, we have block else, some code, and block finally, some code. This is optional, and this is optional. This is needed. Okay, let's try to handle division by zero error. The first that we can do is enter try block into the main code. So please try to print all of these function calls, except exception, print something wrong. And that's all. I have different types of, this is a syntax error, so our program didn't start. Okay, change to the needed. Oh, another syntax error. Okay, so what we have here, we run the function foo with argument 1. It goes without error. In the next, we have 0 division error, but we catch it using try except block. And after catching this error, we go to the exception block operations. And here we print something wrong. But you can see that the next call of the function foo with 2 is not running because we have exception here, and after that we exit the try block and enter except block. How to deal with it? Very simple. We just need to write it not inside our main code, but create this try except block inside our function. So please try to, for example, not return, but our output is equal to 1000 divided by y. And if not, please print something wrong. Okay. Oh, I forgot return. So after our try except block, we can return our out from function.
Out under the try function.
Okay, so it's better to have return here. So we have our first answer. We have exception block output, and our function return nothing. So we have none here instead of 0, instead of number. So our function have no return because we have error here, and go to the except block. And this function looks like a function without returning value for the function print, and so on, print none. Okay, and now we have our last result. What we can do else with the exception? We can handle it as like an object. So we use a special word as here, and name E for storing. This is your choice what name you will have. So you can have exception with lower case letter E, for example, because if you have uppercase, this is a special word, and this is not a special word. But I prefer to use just E. And for example, we can see what methods and attributes the exception object has. So we can see a lot of different methods here. What is interesting for us, it has str dunder method, so we can print the object itself. If you remember, if object has underscore underscore str method, it can't be coerced into the string or be printed inside print function. Okay, what next? What we have interesting here, we have a traceback. It looks like a traceback is the thing that show us the stack of functions. So let's try to first of all print object. So print E, after that print E dot traceback. Oh, traceback is an object. Okay. So let's see what have traceback object inside. So if we print just our exception object E, it shows us this is a division by 0. After that, we print what inside traceback, and we have tb frame, tb last t. Okay, I just want to find where we have our stack. So once again, please print dir E, and what we have here. Of course, to have the type of the error, we can print explicitly type. Please print as type of the error. So this is division by 0 class 0 division error. I will show you the hierarchy of Python exception a bit later. Just want to try to get stack. Context. Tier format, args. Okay, let's Google how to show. Okay, we need an additional model traceback here. Let's try to do it. But once again, we can show it to our user in the terminal without such things as printing traceback, just using accept exception. It will show all the information that we need. Or not. No, it will not show. Okay, let's do it with traceback module. What we have here, print exception. Of course, without these symbols. Yes, now we have traceback, and what we usually have when we have error inside terminal. Why we have two nuns? Interesting. Okay, I understand. We have two nuns because this is already a function to write something into terminal, and after that we try to print the result of this function. So it will print none. To get rid of it, just use a traceback. Okay, and we have the name of the error, the type of the error, and full traceback. So the great choice if you write some program, the huge project or something that must be more clever than your studying material, so you can use different objects to log it, or you can write your own. So you create a file, you So for example, this is some string. You just write this string into the log file. So assume that you have log, just write s into this. And after that, you just look at your logs and try to understand where you have exceptions during runtime without stopping your program evaluation. So let's talk a bit about assertion. You can prevent the errors using asserts like, for example, retesting of the arguments inside function, or retesting some situation when something can go wrong, but you know about it, how it works. So we have our function that divide 1000 by something. And we know that we can't divide by 0. So we can use the special word assert to write the pretesting. Assert y is not equal to 0. And if it is, we will write message. Y is 0. 0 division is not possible. So we will have an assertion error. Here we not have a try except blocks. We just erase error when we have a wrong result in this condition. So the syntax of assert blocks is really simple. You just have special word assert, condition, and optionally a message. So if this condition is equal to false, it will be raised assertion error. It's really good for unit testing of your functions. So what is unit test? These are tests for each function you have in your program. It calls unit because it for one particular thing inside code, and the smallest thing inside your code is a function. So assume you have a lot of functions. You can use asserts here. And you can think about it like unit testing of your code. So the best practice is to cover each function inside your project with unit tests. If you know that something can go wrong when you call this particular function, please try to prevent it. Try to write assertions to arguments, assertion to operations inside functions. So let's do it in this example. For example, here we have x, and it will return x squared. For some reasons, we do not want x to be negative. So x more or equal 0, and the message is x is negative. Here, for example, we have x, and we do not want x to be empty string, for example. Actually, we can use just x because empty string is false. But maybe it's better to use not equal. Not equal is not the best choice because this is an empty string. If x will be, so let's check. We can use a lot of asserts inside one function. Let's first check that type x is equal str. X is not string. And then assert that x not equal empty string. X is empty string. So, and in the main program, I can explicitly write here that this is a main program.
You forgot T in the second assert in function 3.
What I forgot? Okay.
T in assert.
Okay, thank you. If name is equal to main, please. So function foo from 1, function foo from 1 from, I don't know, 2, foo 3 from ABC. So here all must be okay. Foo1 is not defined. Oh, sorry, foo2. How we class str. How we can check that x is a string. Class str class. Just try to remind how to do it. How to check if object is string. Is instant base string. Okay, this is a better choice. If you remember, we have such function for object is instance. Is instance. So X and base string. Oh. Base string with capital B. No. Ah, okay, str. I was right. Okay. Now it's all okay. I think that we can explicitly write that all okay if all our assertion blocks after all our assertion blocks completed. So this was asserts inside the function, but we can use asserts inside our main program when we call functions. So for example, here we can test our function, that function from 1 is equal to 1000. And we can use messages after assertion blocks, we can use messages that our tests are completed. So foo2 from 2 will be 4. Assert foo3 from ABC. Oh, we have no return here. Okay, let's return something. Return X plus exclamation mark. Is equal ABC exclamation mark. Print all tests. Oh, in this manner, we can create assertion blocks for each functions. We can create assertion block for one part of the code, for second one of the code. Call them tests for this, test pro that, and before starting your program, you will have your assertion blocks that will check your functions, because you work with your program not one day, not only for homework. You can work with your program I don't know, maybe for years, and other people can work with it and they can change your function. And if function changes, your assertion blocks must understand that something goes wrong. For example, we have foo2 that returns x squared, but we can change it to returns x squared plus 1. And if we have good assertion blocks, for example, here I have messages, something wrong with foo2. We will have the assertion error here. But it is a separate discipline how to construct your test, because there is a lot of useful information in such case, how to create special objects for testing, how to deal with different types of errors and so on. You can find it in Google. So just, I think in Stepic we have a lot of courses about unit testing and so on. So another way to test your program is not unit testing, but integral tests. What is the difference? If unit tests, they test only the smallest pieces of code like functions. The integral tests use the whole integrated pieces, like large objects that had a lot of methods, relations between objects, and the whole program itself. So integral testing is the combining all tests in one and test the system in the whole with all of the relation between its elements. Okay, what else we can do with errors? So I showed you that we have different types of errors inside Python. So here we have an exception hierarchy from the Python documentation. So all exception objects, they are inherited from base exception, and our interest is in exceptions that is inherited from the exception object. So here they are. For example, where is our divided by 0? It's arithmetical, I think. Yes, it's here. So it is arithmetic error and 0 division error. Okay, why we need a lot of different types? Because we can handle them separately. For example, let's create a new file. We have our function foo that has argument x and y. And we want x and y to be positive. So we use assert x, not positive, but not negative, so more or equal than 0. So x more than equal than 0, please print us that x is negative. Y is more or equal to 0, please write us that y is negative. And after that, we want to have our out to be x divided by y. And in main program, if name is equal to main, please print foo from 1 and 0. So now we will have a 0 division error. Oh no, we have syntax error. So what's wrong? Oh, of course. So yes, we have a 0 division error because y is equal to 0, and we do not check it with the assertion for arguments. What we can do? We can use try except block here. Try to print except. For example, we can use arithmetic error here to accept arithmetic error. So before we use exception, the word exception. It means that please try to deal with all this hierarchy of exception. Please handle all these objects. Now we strict our range of exception that we want to handle. Please use only arithmetic error, and let's do it with like SE. Please print as E. It prints us that we have division by 0. Okay. But we have our assertion. Let's think what will be if we have negative here. The except block will not handle the assertion error because assertion error is here and it's not inside the hierarchy of arithmetic errors. Maybe we will add some additional code here. For example, print that program is ending ends well. Let's just check without assertion error. So yes, we have arithmetic error, but we handle it with a try except block, and our program ends well. What will be if we have an assertion error with our assert? So x will be negative, and we trigger our assert. We have assertion error, and the program doesn't end well. So we want to...
And this happens because try except block is not in the function.
No. It happened because we have here arrays of assertion error. But here in except block, we handle only arithmetics error. We do not think about assertion error here. And it ends the program because we don't handle it. So I just will show you how to handle it, and I think you understand what's going on. Here we can have a second except block with assertion error. Maybe I do not want to use the object itself. Please print that function asserts are triggered. Okay, maybe I want to use E to show what an assertion triggered. So now we have error here. We know the type of the error is assertion error. We go to the except block for the specific error, and we have print this string and print the error itself. So X is negative. And in one try block, we handle two different types of exceptions. There is an universal thing how to handle all exceptions. First of all, you understand that exception will handle almost all exceptions. So this is a parent for the whole bunch of different exceptions, but not for this.
Why in last execution was no information about division by zero?
Because in function we have triggered assert before the implementing of the return code. So we have error here, and we exit the function by raising the exception. So exception was raised here. In the first string, the assertion error was raised, and we exit the function and go to the except block. So we do not run the code after the raising of the exception. So this statement, except exception, will handle all of these errors. So let's try to have some memory name. Oh, for example, name error. Okay, let's try to handle name error. What is name error? For example, we try to use unknown name inside function. Let's change this to 1, this to 1. It satisfies all our asserts, but we have unknown name here. This is not a syntax error, because this is a legit Python code string. So we can divide X by some variable named unknown name and return it. For the view of the interpreter, this is a legit string, but we have a name error. Of course, we can accept name error here, but we want to show how to handle all exceptions. And please print us E. So this is our exception. Name unknown name is not defined. And the program ends well. So we handle named error because we use the parent exception. There is a very bad style to use once again. Oh, I changed my language. So we can use accept block without specifying what exception we want to handle, just with the word accept. And this will handle all the exceptions, including these four. And you know that the keyboard interrupt is responsible for exiting program using Ctrl+C. So if we handle like this, and for example, we have while true cycle inside our program. You must understand that all programs that have user interface, for example, they have while true cycles inside. For example, all computer games have while true. This terminal have while true. Different reductors, editors of text, and so a lot of programs have this while true, because inside we have keyboard interrupting the usual closing of the program and a lot of ways to exit the program. Let's try to use it correct. First, exception, while true, print, I don't know, print time. Maybe I must Google how to print actual time Python. Okay. And maybe I want to sleep sometime because it will really fast. I must, this is a seconds, okay. From time. Okay, sleep 1 second. And each time, please. We already. So the first thing, we run our function inside try block. After that, we run while true. So this is not what I want. I want to be inside while true. So each iteration of the cycle, we will have the call of function with the handling of exceptions. After that, we will have printing the actual time and sleep 1 second. And again and again and again. If we handle exception, it will print us something wrong, and we can exit using Ctrl+C. Okay. Yes. Each iteration we have error, 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 because we have a name error, as I remember. Yes, we have unknown name here. Okay, but we always can close the program using Ctrl+C keyboard interrupt. But if someone was so clever to handle all exceptions inside Python interpreter and used except block without specifying the parent object, we will have the same result. Actually, I want to run it inside a new window. So we have the same result. This is the infinite cycle with the error that was handled and timestamps. Just trying to keyboard interrupt. Oh, it's working. Why so? Maybe I haven't. Okay, I understand. This is working because our while cycle is not inside try block. And the keyboard interrupt is not handled inside this try block. It is outside something here, and it works as usual. Let's try to rephrase. Try while true. Let's print our function. And after that, sleep. sleep 1. Yes, now all the program is inside try block. Okay. It returns from the while true because we go to the except, and the program ends because we have no code outside. So I just need to fix the name error here. So we use Y. And now Control C works. Okay, I just have read that we will have problems when we handle the keyboard interrupt error. Okay, I understand now. So it really works. We handle this error, and instead of, for example, I want to try find the dangerous situation when using the except block is not correct. So assume that we interrupt here with keyboard exit. Then we go to the except block. Oh, okay. Okay, this is a thing. So trying to exit your program is not an error by itself. It's just a user want to exit. But here inside the except block, we can have some code. When error was raised. And we do not want this code to be implemented, to be run when we use Ctrl+C escaping. But it will be run because we handle the keyboard exit handling inside the except block. So my my suggestion is not to use just except phrase and use it with at least exception object. It's much more safer. So all the objects that was inherited from exception are real errors. So arithmetic errors, assertion errors, attribute errors, and so on and so on. And warnings. You can exclude warnings if you want to work without them, because for example, a lot of libraries have warnings that they use another syntax for the new version of the library, but it is still not deprecated. Okay. So the last thing about errors that I want to share with you is that you can create your own error objects. Maybe I want to create a new file. So errors are just usual objects, so we can create it like class. Class my and we can inherit it from, for example, the parent exception class. And we want to use specific parameters. For example, we can rewrite str so just I want to use a specific arguments to create an instance of the class, and after that to define the new str for the exception. So they have a new init with self message. Okay. Okay, let's redefine init for the our class of exception. Let's assume that we have the such situation: def read pasta record as string. Not to read, but for example, count CG in FASTA, not FASTA, in DNA string. For element in S. So if element not in A, C, the special word to raise our, not our, any exception is just raise. Else so our exception will be raised when we have not ACTG nucleotides inside DNA sequence. Let's call it nucleotide error. So init will be like self nucleotide, and that's all. So please raise nucleotide error with parameter nucleotide that is not inside ACTG. And what we have in init, self dot message will be wrong nucleotide. And we use init from the exception class. So if you remember, the super is for class that is a parent of the current class. So we use init from exception using self.message as argument. Okay. And after that, please count CG in DNA string ACTGU. Syntax error, def init without semicolon. End of line, end of line. Oh, okay. The wrong symbol. Yes, we have our own nucleotide error. So we add our error class to this hierarchy like a child from the exception. So we have arithmetic errors, assertion errors, and now we have nucleotide error. And we can handle it explicitly. So we can use try except block. Try to count ACTGU except exception. Accept exception as E, print E. And here, please print that program and well, yes, we handle exception, our own exception, like a child of the all exceptions. We have a message that we have wrong nucleotide U, and our program dents well. And of course, we can handle it like a nucleotide error now. Nucleotide. Okay, seems like good. Yes, the same result. We successfully handle it. When this is useful, when you have your specific problems inside your programming code. So here, this is a specific problem because Python knows nothing about nucleotides. It knows nothing about the genetic code and such things. And to work with such errors, you can, and I think you must create your own objects to explicitly tells for another programmers and for users of your program what goes wrong. So here we say, please look at your string, you have a wrong nucleotide U, and you can understand what's going on. And of course, we can use a traceback like I did before. So import traceback, print e, traceback dot, I forgot actually how to show. Print exception. So now we can show for programmers the stack of the error. So wrong nucleotide U, the traceback. In file own error.py in line 19, we call the function count CG in DNA strings, and we raise nucleotide error because we have a wrong nucleotide U. So one of the feature of your programming code is to be as much explicit as you can to show users and other programmers what is going wrong. And it is very helpful when your project become large. So to work with it in the professional level, please try to read materials or watch courses about testing, about unit testing, about integral testing. And of course, you can handle other programmers' runtime errors using try except block and a lot of things actually. Errors object and all of such abstractions are really powerful instrument to work with runtime errors. So if you understand how to deal with it, you can handle errors that are not critical for you and proceed the running of your or someone else's programs without any problems. So please, very quickly, if you have questions today.
I have a question about exam and how many
Okay.
lectures left.
So as I know, your exam will be at 11th January, and it will be like your midterm on Stepic. And I still think how to deal with those who have bad marks for midterm. It's not so bad, but I want to have to create some project for them to try to increase their marks. So your exam will be at 11th of January on Stepic.
And we'll have lecture on next Wednesday.
Yeah, I think yes. Why not?
Okay, thank you.
Okay, Professor, the exam will be like midterm only, as there was last exam like that.
Yes. Yes.
Okay.
But of course, I will think about another way to pass or to increase your marks. Maybe like in talk about themes that was covered. But the main exam will be on Stepic. You will write your code there, like in midterm.
Like we have given the earlier exam,
Yes.
same
Yes.
exam will be like on
Yes.
11th January. Okay.
Okay, thank you. You have another studies, so goodbye.
Goodbye.
Bye.
Bye.